So hello everyone again. This may be the last lecture or one more lecture is required for electromagnetic induction. So welcome to lecture 7 part 2 of electromagnetic induction. I am Sameer Lavankar. So let's begin our discussions. So course outline, this may be the final outline for you. So introduction, that is definition of electromagnetic induction is done. Experiments of Faraday and Henry, 3 experiments were being explained to you in detail. That was the basic outline of electromagnetic induction, how it was produced, what the scientists were thinking at that time. So that thinking, that small experiments led to the mass generators, mass electromagnetic generators, mass hydroelectric power plants being used for the basic concepts of EMF being produced due to a changing magnetic field or changing effective area. Then magnetic flux, that is phi b, Faraday's law of induction, that is EMF produced, Lenz's law in conservation of energy, motion electromotive force, that is epsilon is equal to B L V, inductance, self inductance and mutual inductance, and finally AC generators. So in this lecture I will first of all summarize everything again, and then we will move on to some of the problems related to every concept of electromagnetic induction. So this is the final formula sheet here. So this has everything you need to know regarding electromagnetic induction. So now let us move on to the summary here. So the let us look over every of the point written here. So first of all, the magnetic flux through a surface of area A placed in a uniform magnetic field B is defined as phi b is equal to B dot A. We know that it is a dot vector product. It is a dot vector product. It is a dot vector product, that is equal to B dot A, which is equal to B A cos theta, where theta is the angle between B and A. Second is Faraday's law of induction imply that the EMF induced in a coil of N turns is directly related to the rate of change. Please make sure it is rate of change of flux, rate of change of flux. Hence epsilon, that is voltage, that is EMF produced, is equal to minus and d phi b by dt. Next was here phi b is the flux linked with one turn of the coil. If the circuit is closed, a current I is equal to epsilon by r. This is a typical current electricity formula. I is equal to epsilon by r is set up in it, where r is the resistance of the circuit. Next, Lenz's law. So Lenz's law states that the polarity is nothing but, in mathematical terms, this is positive or negative value. It is positive or negative value of what? Of induced EMF. Induced EMF is nothing but this value only, this concept only. So Lenz's law states that the polarity of the induced EMF is such that it tends to produce a current which opposes the change in magnetic flux that produces it. The negative sign is in the expression of Faraday's law indicates the fact. So this is nothing but the generation of Lenz's law. Not generation, it is a typical example of Lenz's law, that how is Lenz's law valid. Next concept, fourth. So when a metal rod of length L is placed, this is the concept of our motional electromotive force. So when a metal rod of length L is placed normal to a uniform magnetic field B and moved with a velocity v perpendicular to the field, the EMF induced, also called as motional EMF, across its end is epsilon is equal to BLV. The complete formula how it is derived is being told in the concepts in the lectures of motional electromotive force. Next, changing magnetic fields can set up current loops in nearby metal, or the basic concept of electromagnetic induction. So changing magnetic fields can set up current loops in nearby metal, any conductor bodies. They dissipate electrical energy as heat. Such currents are called as eddy currents. So small concept of eddy currents, the application of eddy currents are being also dealt just before inductance. So this was the concept of eddy currents. More detail is being told to you in the chapters, in the lectures of eddy currents. Next, inductance is the ratio of flux linkage to current. So it is equal to N phi by I. So inductance was calculated as we already know that N phi was directly proportional to, let us say, L, and when we remove the proportionality thing, then it is, not L, I. When we remove the proportionality, it is this value, and if we just rearrange the terms, we get L is equal to N phi by I. So, N phi by I is written here. So, this is the simple concept of inductance. Just a quick recap of mutual and self inductance. So, for mutual inductance, let me write first. So, this is mutual, this is self. So, let us say for mutual there is requirement of 2 coils, for self there is requirement of 1 coil only. So, let us say we need to calculate the value of flux linkage in first. So, it is nothing but N1 phi 1, and it will be directly linked or directly proportional to the current passing through the coil, neighboring coil. So, what is neighboring coil? We will denote by subscript 2. So, it is equal to I2. Hence, if we remove the proportionality sign, we get this is equal to M. So, it will be the mutual inductance in coil 1 due to 2, and similarly N2 phi 2 is directly proportional to I1, and hence N2 phi 2 is equal to M21 I1. For self, it is a simple concept of N phi directly proportional to the current passing through it, and hence N phi is equal to L multiplied by I. So, this was the concept and for the difference between mutual and self inductance. This was the formula being used for mutual inductance. Also M21 is equal to M12, and this is the formula for self inductance. Moving on. So, a changing current in a coil 2 can induce an EMF in a neighboring coil, that is coil 1. This relation is given by this value. So, we can find out the EMF produced due to changing current in neighboring coil. So, this relation is given by epsilon 1 is equal to minus M12 di2 by dt. The complete derivation of this formula is being discussed when we were discussing the mutual inductance concept. So, you can see that thing in that lectures also. For now the formula is important to us, that is epsilon 1 is equal to, what does epsilon 1 means? The EMF produced in coil 1, there is nothing, no other significance of 1 here, it is EMF produced in coil C1 due to the change in current with respect to time of coil C2. And what does M12 means? M12 is the mutual inductance of coil C1 with respect to coil C2. So, the quantity M12 is called the mutual inductance of coil C1 with respect to coil 2, that is the same thing I told right now. One can similarly define M21. So, M21 is nothing but mutual inductance in coil C2 with respect to C1. So, one can similarly define M21. There exists a general equality, that is M12 is equal to M21. Next point. When a current in a coil changes, as in with respect to time the value of current will change. So, that means if at t is equal to 0, the current is let us say 0, at t is equal to let us say 5 seconds the current value changes to 5 amperes, and at t is equal to 10 seconds the current value is 10 amperes. That means there is a variation in current value. So, this is the thing only told here, that when a current in a coil changes, it induces a back EMF. Back EMF, I told this concept to you, that the EMF produced in a self coil, when we are talking about self inductance, it is called as back EMF. So, this is a simple physics definition, nothing huge behind it. So, when a current in a coil changes, it induces a back EMF in the same coil. The self induced EMF is given by, so self induced EMF is also called as back EMF. So, self induced EMF is given by epsilon is equal to minus L di by dt. I think this formula is also given to you, yes. So, this formula is also given to you here. So, the self induced EMF is given by epsilon is equal to minus L di by dt. Please make sure that what the self induced means? If the current was passing through the same coil, so there was a change in the magnetic flux. If the change was in magnetic flux was happening there, then the EMF was produced in the same coil only. Because everything was self, so the induction was also self, and hence self induced EMF came into picture. And a different name of this self induced EMF is back EMF. So, L is the self inductance of the coil, it is a measure of the inertia of the coil against the change of current through it. So, when we were talking about the self inductance concept, we got to know that the value of L, the value of, that is, coefficient of self inductance was analogous to the mass, value. So, when we calculate how did we find it analogous, just a quick recap. So, when we calculated the value of work done, we found the work done was half L I square, and for mass the work done will be in terms of kinetic energy. So, kinetic energy was nothing but half m v square. So, from here we found this to be analogous. So, we said that L is nothing but electrical inertia and m is mechanical inertia, and similarly I and velocity are analogous. So, this is how we got to know that L is electrical inertia. So, just a quick iteration again of the last line here. So, L is the self inductance of the coil. It is a measure of the inertia of the coil against the change of current through it. So, this was the last line here. Moving on. So, the self inductance of a long solenoid here means that L, let me write here only. So, long solenoid means L is greater than R. The self inductance of a long solenoid, the core of which consists of a magnetic material, core as in the inside part. So, let us say that this, let me make it much bigger so as to iterate the same thing. Let us say this is the solenoid, this is solenoid we are talking about. So, let us say these are the coils. So, here this thing, this portion, this metallic conductor is nothing but core. These are the wires. Please make sure that the wire should be a conductor. The inside part should be a conductor of electricity, and outside part should be a insulator of electricity. So, the self inductance of a long solenoid, the core of which, so I told you what is the core here, the core of which consists of a magnetic material of permeability mu r. So, air is not present this time, a different material is being present, hence we need to multiply the value of mu r with the self inductance or mutual inductance value whichever is talked about. Here self inductance is talked about, hence we need to multiply the formula of mutual inductance, self inductance with the relative permeability coefficient. So, the self inductance of a long solenoid, the core of which consists of a magnetic material of permeability mu r, is given by L is equal to mu r mu naught small n square into capital A into small l. So, this formula is also given to you here only. Everything is here for your quick reference. The formula part, where A is the area of cross section of the solenoid, L is its length. So, A is the cross sectional area, L is the length, and small n is the number of turns per unit length. So, small n is nothing but capital N upon small l. So, this point is also done. Next, 10th, that is in an AC generator. I think this is the last point. Yes, this is the last point. So, in an AC generator, mechanical energy is converted to electrical energy by virtue of electromagnetic induction. This line is being told to explain to you several times. So, mechanical energy as in rotator shaft either using gears or for a simple, very simple generators using your hand movement for rotating the shaft. Mechanical energy is converted to electrical energy. Hence, as EMF is produced due to change in the effective area or due to change in the direction of the magnets, there is a EMF produced, and due to this EMF produced, mechanical energy is converted into electrical energy. And by virtue of what? By virtue of electromagnetic induction. Next, if a coil of n turns and area A is rotated at v new revolutions per second, so nu is the frequency here, in a uniform magnetic field B, then the motional EMF produced is, so the motional EMF produced is epsilon is equal to NBA omega. So, this term is nothing but omega into sine omega t. we also know that omega is nothing but 2 pi f. Here we are denoting f as nu value. So, this is nu. So, it is 2 pi nu. So, epsilon is nothing but n b omega sin omega t. So, this formula is also given to you towards the right, where we have assumed that at time t is equal to 0 seconds, the coil is perpendicular to the field. The coil is perpendicular to the field. So, this is the simple assumption being told that at time t is equal to 0 seconds, the coil is perpendicular to the field. So, this was the complete summary. This is the end of electromagnetic inductions theory part. I will explain some of the problems so that you understand the concept, you can apply the concepts nicely, and then finally this will be the end of electromagnetic induction. Quick recap. So, magnetic flux is denoted by a symbol phi b. It has a unit Weber, that is WB. So, dimensions are given to you here, and equations. So, equation of magnetic flux is phi b is equal to B dot A. So, B dot A is given to you here. EMF is denoted by epsilon value. So, epsilon is here, epsilon is here, has a units of voltage, dimensions are given to you here, and epsilon is equal to minus d n phi b by dt. So, this is the formula being used here. Next is mutual inductance M, has a unit of Henry, capital H, this is the dimensions here, and epsilon is equal to minus m di2 by dt is the equation. Either the mutual inductance equation can be this, or with the change in some of the subscripts here, this epsilon value, this epsilon equation can also be used. So, equations as in wherever the concepts are being involved. The equation does not mean that magnetic flux is only and only this equation, even phi b value is also used in epsilon terms here. Next is self inductance. Self inductance is denoted by the letter capital L, unit of Henry, and the dimensions are this, and hence epsilon value is minus L di by dt, the same formula here. So, this is the final summary. Let us move on to the problems. So, please look over the problem here. The first problem states that a long solenoid with 15 turns per centimeter. So, small n is given to you as 15 turns per centimeter. For unifying for the same dimensions, we will change this per centimeter into per meter, and hence this will be equal to 15 turns per centimeter. So, it is centimeter inverse, that means it is 15 into meter inverse, that is equal to 1500 turns per meter. Small loop of area A, again it is into centimeter square, so we will change it into meter square, that is 2 into 10 to the power minus 4, because 10 to the power minus 2 ka square, it is 10 to the power minus 4. So, small loop of area A, that is 2 centimeter square, placed inside a solenoid normal to its axis. If the current carried by the solenoid changes steadily from 2 to 4 amperes, that is dt is given to you and di is given to you. Please make sure di is given to you, dt is changed to you. So, if anything regarding di and dt is given to you, then maybe the question will be something about calculating the value of EMF produced due to change in current. Let us move on. So, what is the induced EMF? See, the question is that only, that the induced EMF has to be calculated in the loop while the current is changing, that is di is changing, di by dt is changing, and you need to find out calculate the value of EMF produced. So, please look over the solution now. So, these are all the given value terms here, small n is given to you, capital A is given to you, di is final minus initial, hence it will be plus 2 amperes, and dt is given to you, dt is always positive. Moving on. So, EMF in the solenoid is nothing but d phi b by dt in negative sense. We know B is equal to mu naught Ni, we calculated this, we know this concept from when we were deriving the concepts of mutual inductance and self inductance. So, we know B is equal to mu naught Ni, where mu is given to you here. So, I can write it in the equation also, in the question also, that mu naught is given to you as 4 pi into 10 to the power minus 7 Henry per meter. So, now mu naught is given to you, n is given to you, I is given to you. Hence, epsilon is equal to nothing but a mu naught and di by dt. So, a simple equation we just put this here value. So, phi b is nothing but b dot a, which is equal to mu naught n I a, as only I is vary and everything else is constant, so it is mu naught Na into di by dt, and this is the same formula being used here. So, now a typical substitution of everything. So, A is given to you as like this, mu naught is given to you like this, N is given to you like this, and di by dt is given to you like this. So, di is also given, dt is also given, there is no use of any differentiation here. So, just putting these all formulas, we get 7.54 into 10 to the power minus 6 voltage as our answer, that is the EMF produced. Hence, the induced voltage in the loop is 7.54 into 10 to the power minus 6 volts. So, let me conclude this lecture here only. The next lecture may be the last lecture for electromagnetic induction. In that lecture, we will talk about some more problems regarding electromagnetic induction only. It may be related to concepts of magnetic flux, EMF produced, mutual inductance, self inductance, and AC generators. So, for now, thank you.